Hello everybody, today we'll be learning about sample spaces and theoretical probability. So first we'll start with some vocabulary. First we have something called a probability experiment, and this is an action or trial that has varying results. So let's say we're rolling a die and we want to find the probability that we roll a 3. That would be a probability experiment. Outcomes are the possible results of a probability experiment. So looking at that same example for rolling a die, the possible outcomes or results are 1, 2, 3, 4, 5, and 6, since those are the numbers on a die. And then an event is a collection of one or more outcomes. So an event would be rolling a 3, that would be an event, or we can have more than one outcome. So for example, rolling an even number, that would be an event. And then we have something called the sample space, and that is the set of all possible outcomes. So in the same example, the sample space would be the numbers 1 through 6. So for this first set of examples, we're going to find the number of possible outcomes in this sample space, and then we're going to list the possible outcomes. So we're finding all of the possible results that we can get from this probability event. So number 1, I have that we flip a coin and roll a 6-sided die. So for flipping a coin, we know that we can either get heads or tails. So I'm going to make a tree diagram to find the outcomes in the sample space. So I have heads, which we'll just write an H for heads. And then I could also have tails. That will be our first 2 possible outcomes. But then after that, we're rolling a 6-sided die. So after I, for instance, flip heads, I have 6 outcomes that can come after that. I can either roll a 1, 2, 3, 4, 5, or 6. And then I have those same possible outcomes for tails. I could roll a 1, 2, 3, 4, 5, and 6. So looking at all of my possible outcomes then, I could have heads to 1 through 6 or tails through 1 through 6. So that means that there are a total of 12 possible outcomes. Then it asks us to list them out. And so I'm just going to again use H for heads, T for tails, and that means I can have H1, H2, H3, H4, H5, H6. And then if I flip instead of tails, I could have the possibilities of tails and 1, tails 2, tails 3, tails 4, tails 5, and tails 6. Now let's look at one more. So number 2 says you draw 2 balls at random without replacement from a bag containing 2 red balls and 4 purple balls. So looking at that first draw, we can either draw a red ball or we could draw a purple ball. So I'm going to have R for red, P from purple. Now after I draw a red ball, since we're not replacing the balls, that leaves me with 1 red ball that I can choose or 4 purple. And so those are the options there. Now if I draw a purple ball first, that leaves 2 reds left that I could choose. And then since I've drawn 1 purple, that leaves 3 purple balls left. And so these are all of my possible outcomes. So counting that up, that means I have 10 possible outcomes. Now some of these are repeats, but we need to have those repeated just so that we can see those, the amount that each of those can happen. So for looking at that first tree right there, I could draw a red, 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 purple, red, purple, red, purple, red, purple. So there's a pretty good chance of drawing a red first and a purple from that. And then on the other tree, I could draw a purple and then red, purple and then red, or just 2 purples.